This is an applied problem. A rectangular home office has a diagonal of 20 feet and a perimeter of 56 feet. What are the dimensions of the office? Well, let's begin by familiarizing ourselves with the problem. And let's just assign variable names to the dimensions, to the length and to the width of the office. Let's let L equal the length. And let's let W equal the width. And we know that these dimensions are going to be in feet. Now, if we would make a little drawing of the office, it's a rectangle. We said the length is L and the width is W. And here's the diagonal. We said that that's 20 feet. So these variables in this drawing will help us translate to a system of equations. Let's do that. Because the diagonal is 20 feet, we can use the Pythagorean equation to get one equation in our system. We can say that L squared plus W squared is equal to 20 squared. And we know that the perimeter is 56 feet. We find the perimeter of a rectangle by multiplying 2 times the length times 2 times the width. So the perimeter, 2 times the length plus 2 times the width, is equal to 56. And let's see what we have here. We can write L squared plus W squared equals 20 squared as L squared plus W squared equals 400 when we square 20. And with this equation, if I divide by 2 on both sides of the equation, I get L plus W is equal to 28. So now I'm ready to solve this system of equations. I have L squared plus W squared equals 400, and L plus W equals 28. Now, I'm going to use substitution to solve this system. I'm going to solve the second equation either for L or for W and then substitute into the first equation. And let's just choose to solve this for L. When I solve this equation for L, I subtract W on both sides and I get L is equal to 28 minus W. Now I'm going to substitute this into the first equation and solve for W. So I would have L squared, or 28 minus W squared, plus W squared is equal to 400. And when I square 28 minus W, I get 784 minus 56W plus W squared, and then I have this other W squared here. That's equal to 400. Now, if I add the W squareds together and subtract 400 on both sides of the equation, I get the quadratic equation 2W squared minus 56W plus 384 is equal to 0. And I can divide both sides of the equation by 2. That gives me W squared minus 28W plus 192 is equal to 0. Now I can factor on the left-hand side, and I get W minus 16 times W minus 12 is equal to 0. So we can see that the solutions of this equation are going to be W equals 16, which is what I get when I solve W minus 16 equals 0, or solving W minus 12 equals 0, I get W equals 12. Now, we've found W. We have W equals 16, or W equals 12. If W is equal to 16, remember we had the equation that L is equal to 28 minus W. So if W is 16, then L is equal to 28 minus 16, or 12. And if W equals 12, then L is equal to 28 minus 12, or 16. So we see that in either case, the possible dimensions of this room are 12 feet by 16 feet. And let's check those possible answers in the original problem. Since we usually consider length to be longer than width, I'm going to check L equals 16 and W equals 12. Now, first of all, we want to see if a room with this dimensions has a diagonal of 20 feet. So we check 16 squared plus 12 squared, which is 256 plus 144, or 400, and that is equal to 20 squared, so that part checks. And now we also need to check to see if the perimeter of a room with these dimensions is 56 feet. So we're checking to see if 2 times 16 plus 2 times 12 is 56, and I have 32 plus 24, which is 56. So now we're ready to state the answer because the answer does check. We say the length of the room is 16 feet and the width is 12 feet.